Good evening. My name is Partha Majumdar. I'm a student of this LLM program from IISc. I first of all would like to thank for this program. It has been an extremely good program. I've learned a lot, but this what I've learned is still the tip of the iceberg, especially what I've understood. So I have a lot more to study in this subject, and I hope to do that. As a part of this program, I have made a project. So I will share you the project. So I included this in my research center. So there are other tools which I also have. So this is a star right now. So this is what is the tool, Bhasha Setu. So it's an English to Hindi translator. So before I demonstrate the translator, let me tell you a little bit about the translator, how it was developed. So here is the complete code of the translator, and let me show you the model builder first. So this is where I built my model. So I am basically fine tuning this model called Helsinki NLP Opus MTENHI. Now, to fine tune this model, I've taken a corpus of 1.6 million data points. Now, these data points are taken from Hugging Face as well. So this is the place I took the data points from: CFILT, IITB, English, Hindi. So there are 1.65 million data points that I took, and 50,000 I kept for validation, and 2,500 for testing. Now, after cleaning the data set, actually I got around about 1.3 million data points, which was the training data. Now, to train the model, I tried initially to do it on my local machine, which has got 4 GPUs. However, it was not possible. It was crashing. So ultimately, I resorted to using AWS. And AWS, I took a EC2 instance, G5 V-Large NVIDIA GPUs. And it took around about 16 hours to train the final round of training. Now, though I had tested the model on my local machine before putting it on AWS, still I required about 3 rounds of checking and correcting a few things before I could ultimately train my model. The total cost of training on AWS came to $90 roundabout, but it was a worth exercise. So apart from this model training, I have this Gradio app. The Gradio app does a few things apart from giving the UI for um, for the translator. It also does a few things. It does a language detection. It detects whether the input is in English, and if it is not, it rejects the input. Also, it does a name entity recognition. So, in case there are some names in the input which are proper nouns, it restores them and gives it back as it is. However, this feature is not working very well. It doesn't recognize Indian names, so that's a problem which I have to solve. Let me show you the demo of the system now. So here I have the system. So I take a input. Let's say I take an input like this, and let's translate this. So I do this and I say translate. So it will translate. And so if I look at this, so if you read this particular stuff and I read the Hindi stuff, it is a very good translation actually. It's very accurate. In fact, when the model was being trained, the validation point was the blue score, and the model scored 29.5 on the blue score. 29.5 is a fairly good score. However, still the effort has to be made. I have to make the effort to raise the blue score to around about 60 to 70. Now, let me show you some weakness of the model. So I gave an input which is small, so it worked very well. But if I increase the size of the input, so let me say I increase the size of the input and give it to the model will not function so effectively. So when the input size it truncates in between. This is happening because in the Gradio app, I have The number of tokens, what it is generating at the max is 256, because of which it truncates. So here, this is the constraint because of which the output is not coming out very well. Now I have an immediate solution for this. So immediate solution is that if I get a large piece of text, let's say one paragraph or many sentences, and I can break up the paragraph into individual sentences and translate them one by one and then concatenate them back and put it as the output. That is one technique. And if there are multiple paragraphs, I can do that again. I can break up the number of paragraphs into individual paragraphs and each paragraph into individual sentences, and I can do the same thing. But that's not a solution. I have to find a way to increase the number of output tokens so that the model works effectively. Like I told you, it does a language detection before translating. So if I provide this as an input, so it should complain about it. So if I do this, so it says that input text is not in English, please enter English text only. So it does that. So let me try to see whether it works for name entity relationship. So if I say, hello, John, how are you? So you see, it is not detecting the name entity very well. But the rest of the translation is quite all right, but the name entity detection is not happening very effectively. This is a bug which I have to fix. So, okay, that's about it for the demonstration. I have nothing more to say. I appreciate your comments. Thank you very much for your patience.